project is sponsored by PCBWay. Don't forget to visit the PCBWay open source community, where you will find countless useful projects divided into different categories. Choose your area of interest, where you will find many useful and free projects. You can here also download Gerber files or order ready-made PCB for some of your projects. PCBWay has all the services you need to create your project at the best price. Hello, the idea for this project came from a local electronics magazine called Emitter, issue 1213 from 2013. In that article, the author described the construction of high-quality single-ended tube amplifier based on the well-known PCL86 vacuum tube. Single-ended amplifiers are highly appreciated among audio enthusiasts because of their excellent sound quality and the warm natural character often referred to as the classic tube sound. The main disadvantage is the relatively low output power compared to push-pull designs. At the time of building this project, I have several PCL82 tubes available, so I decided to modify the original design to work with the PCL82 instead of the PCL86. Although both tubes contain a triode and power pentode, they differ significantly in their electrical characteristics, pin configuration, and heater voltage requirements. Because of these differences, several modifications were necessary to achieve operating conditions and performance similar to those of the original PCL86 amplifier. The most important changes included rewiring the tube socket to match the different pinout of PCL82, adjusting the cathode bias components, modifying the screen grid circuitry, and optimizing the operating points of both the triode and pentode sections. These changes allowed the amplifier to operate reliably while maintaining performance close to the original design. Inside the enclosure, the amplifier is built around a compact and modern power supply arrangement. Instead of using bulky and often expensive mains power transformers, the entire amplifier is powered from a 12-volt DC source. A small DC-DC boost converter generates approximately 230 volts for the tube's anode supply, while a second boost converter provides the required 16-volt heater voltage for the PCL82. This approach significantly reduces size, weight, and cost while keeping the project simple and practical. The circuit itself is straightforward and follows the classic single-ended tube amplifier topology. The triode section of PCL82 operates as a voltage amplifier, increasing the level of the incoming audio signal. The amplified signal then coupled to the pentode section, which provides the power amplification required to drive loudspeaker through the output transformer. The output transformer, salvaged from an old non-working tube radio, matches the high impedance of the tube to the low impedance of the loudspeaker. For demonstration, the audio source is the line out of my PC. Although the actual sound quality cannot be fully appreciated through a video recording, the amplifier produces a warm, smooth, and pleasant tube sound in real-world listening conditions, which was the primary goal of this project. One practically interesting aspect is the power supply. Despite using switching DC-DC converters, the amplifier is completely free from audible hum and switching noise, even with the volume control set to maximum and no input signal connected. The switching converters operates as a frequencies above 30 kHz, well beyond the audible range, and careful grounding and layout techniques ensure silent operation. The output power of this amplifier is relatively modest, approximately 1.5 to 2 watts, which is typical for a single-ended amplifier of this type. However, when paired with an efficient loudspeaker rated above 90 decibels on watt on meter, this power level is more than sufficient for comfortable home listening. Now I will play parts of a few tracks as a demonstration. Without an input signal, with the potentiometer at the maximum, there is no noise at all, no hum or buzzing from the speakers. No signal input and signal input. In conclusion, this inexpensive and relatively simple amplifier demonstrates that excellent tube sound can still be achieved with a minimal number of components and a compact modern power supply. For stereo operation, two identical amplifiers would be required. Because of its clean sound and moderate power output, the design is also very well suited as a high quality amplifier for a PC sound card, smartphone audio output, or other line level audio sources. I hope you enjoy this project and find it useful as inspiration for your own vacuum tube audio experiments.